Okay, today we are looking at the proof of this formula. So if you have started arithmetic series, then you would have learned this formula, that the sum to n terms is given by this formula n over 2, and then in brackets 2a plus n minus 1 times d. All right, we remember that n is the number of terms, a is the first term, in there again is the number of terms, and then d is the constant first difference. Now, we do need to know how to prove this formula for matric finals and for probably all of your tests and exams that you will be writing this year. You need to know this proof. Now, the important thing is that the proof of this formula relies quite heavily on this formula, which you learned when you were doing just arithmetic progression. So a plus n minus 1d. We need to remember that any term in this number pattern can be given by that formula. So we have to prove this formula using this one. Now remember that if you have something like, I'm just doing this as an example. So this line is actually not a part of the proof. It's just an introductory example. If you are asked to find the sum to 10 terms, of course you can use this formula if you have your A and D values, but basically what you can also do is you can just add the 10 terms that you have together. So you will start by saying term 1 plus term 2 plus term 3 plus, then you have a whole bunch of terms. Your second last, let me just add a plus there. Your second last term in this series that you are adding will be term 9, and then the last term is term 10. So those are all the terms that you would have to be adding together. Now, for the first line of this proof, we are going to be using this same layout. We are going to say that the sum to n terms, so this is now the first line that you would write in the proof. The sum to n terms will be term 1 plus term 2 plus term 3. Now, this first line, you also don't really need to write down. It's also just a bit of an explanatory line, I suppose. Right, now guys, if you are finding the sum to n terms, that means that you have n terms in this number pattern. So the last term is going to be term n. The second last term is going to be term n minus 1. Okay, the last term will then be term n. Okay, if there are n terms that we're adding together, the last one that we will be adding is term n. Okay, so now we would write that as term 1 we know is actually a plus term 2. If we are using this formula, term 2 is a plus. Now, if it's term 2, that means that our n value is 2. So term 2 is a plus 2 minus 1d. 2 minus 1d is just 1d. So term 2 can be written as a plus d. Plus term 3, if we're using this formula and we're putting a 3 in the place of n, because now it's term 3, so n is 3, it will be a plus 3 minus 1d. 3 minus 1 is 2, so a plus 2d. Then we do a dot, 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 plus. So maybe if you want, you can just write as an explanatory, just a little note above, that is term 1, this is term 2, this is term 3, okay? We are just adding them all together. And then your last term, term n, we're just going to use this formula for it. But for your second last term, if we're using this formula, if n now has to become n minus 1, there where we have an n, I'm going to have to put in an n minus 1 instead. So it's going to be n minus 1 minus 1d. So we're going to have to write it like this, a plus n minus 2d, in fact, because n minus 1 is n minus 2. So that is term n minus 1. That's the second last term. And then I'm running out of space here, but I'll squeeze it in. The last term is a plus n minus 1d. Okay, so this represents term n minus 1, and this represents term n, the last term. Okay, so we are writing that down. Then, for the purpose of this proof, we are now going to say plus Sn again. Now what we're going to do is we are just going to swap around the order of all of these terms, because if we're looking at this red line here, if you add term 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, in that order, you will get the same answer as when you're adding term 10, 9, 8, 7, 6 if you're going backwards. If you're adding all of the terms together, but just in a different order, you'll get the same answer, right? 2 plus 3 is the same as 3 plus 2. So you can change the order in which you add things together. And that is what we're going to do for the next line. Okay, so the important thing for this proof is that you are able to set up your first line. Then for the next line, you're just going to take all of these terms and you're just going to write them in reverse. So we're going to write term n first, then n minus 1, then 3, 2, and then 1. Okay, so we're going to do a plus n minus 1d plus, so we're done with that one. The next one was a plus n minus 2d plus, and then another plus, so we're done with that one now. And now we're going to write term 3, a plus 2d plus the next one, a plus d, and then finally we are writing term 1. Okay, so you're just writing all of the same terms that you had in the first line, you're just writing them the other way around. Okay, now we are going to draw a line underneath this. And what we are now going to do, I think you should remember in primary school, especially when you learned how to add bigger numbers together, you would write them underneath each other and then you would add up all the numbers that line up. So we're going to do the same thing here. We are going to add this a with this a plus n minus 1d. Remember we put a plus there, so now we're going to add all of these things together. So firstly, Sn plus Sn is going to give us 2Sn. All right, now I'm going to use a highlighter just to make this a bit clearer. We are going to add that a and this a plus n minus 1d. We're going to write down the first terms that we wrote in these two lines. So a plus n minus 1d is going to give us 2a plus n minus 1d. That is what we get when we're adding term 1 in this line with the first, actually term n, right, in the second line, when we add these first two parts together. We get 2a because a plus a is 2a plus n minus 1d. Okay, now I'll use a different color highlighter so that you can see. Next up, we need to add this a plus d to that a plus n minus 2d. Now that one isn't as easy to see as this first one, so I'm just going to write it on a different piece of paper here so that you can see how that will work. Let me actually just do it on this backing. So if we have a plus d plus a plus n minus 2d. Now guys, you don't have to show this working as a part of the proof. I'm just explaining how we are actually going to get the sum. So this was term 2 from the first line, and this was term n minus 1 from the second line. So they were lining up, so we're adding them together. Now I think it's easy to see that again we have a plus a, that is 2a. And then we're left with, now I'm just going to write it out again, so that's a bit easier to see. We are left with these two terms that we need to add together. Now, guys, it's important to notice that in these two terms, we have a common factor of d. All right, so we've already added the two a's together, so we're done with that. We don't have to worry about that anymore. But here with these two terms, we have a common factor of d. So in order to add these two terms together, because it's not just a number in front plus another number, it's a bit more complicated. In order to add them together, I'm going to take this d out as a common factor and see what happens. So we get 2a plus, if I take d out as a common factor, remember I'm supposed to write whatever is left when I divide by that d from this term and from that term in a second bracket. Now, if I take this term d divided by d, that is 1. Then the next term is positive, so I'm going to put a plus there. If I take this whole term and I divide it by d, the d's will cancel out. I will be left with n minus 2. So that is actually what I'm going to have. Now, if we simplify this, we have an n, and then we have 1 minus 2. 1 minus 2 is actually negative 1. So I'm going to have n minus 1 in this bracket. So I'm going to have 2a plus n minus 1 times d. Or if you wanted to write that d in front, it would mean the same thing, right? If you had d times n minus 1, that means the same as n minus 1 times d. I'm just writing it in this form because this is how the formula is used, how it appears on the formula sheet. Okay, so with that knowledge now, we can see that this a plus d plus that will also give us 2a plus n minus 1 d. Then I'm just going to do a plus dot dot dot. We don't have to show it for every single pair, but it will actually happen. We are actually going to get 2a plus n minus 1d from every single pair. What I'm just going to do, I'm just also going to highlight this in purple because we got this 2a plus n minus 1d from that. And then the second 2a plus n minus 1d came from the blue. All right, now for purposes of this proof, I'm just going to do the last ones as well. So if we're looking at term n here and term 1 here, I'm going to highlight them in yellow. Right, again we have a plus n minus 1d plus a. Again, a plus a is 2a, and then I have a plus n minus 1d. Smudged there, sorry about that. Okay, now, like I said, for all of these pairs that we're going to add together, we're going to get the same answer. We're going to get 2a plus n minus 1d. See, that is where that comes from in the formula. All right, so we've proved this part of the formula already. We're seeing that we're getting 2a plus n minus 1d. Now, I want you to think about how many of these pairs will there actually be. If I have n terms here, that I'm adding to n terms in the second line, I'm going to have n answers. N pairs that I'm adding up is going to give me n of these. So we can write just the first two again, just to show that it is repeating. Dot, dot, dot. And then instead of writing this for the last term, I'm just going to say 2 n terms. Right, if I'm adding n values to n values, I'm going to get n answers. So that is why I'm saying that this pattern will repeat to n terms. Now guys, if there are n of these, instead of writing them out n times, I can just put an n in front of the whole thing. So I can say this, I can say that this is actually equal to n times this repeating answer that we're getting, because there are n of them, right? If there were 5 of these in a row, I could say that it would be the same as 5 times this bracket. If there were 10 of them, I could have said that 10 of them in a row added together is the same as 10 times the bracket. But now, because there are n of them, I'm saying that this n of them in a row added together is the same as n times this. Now remember, we're wanting Sn at the moment. We have 2 Sn, so we need to divide that side by 2. And that is where the n over 2 actually comes from. N over 2 times this whole bracket. Now guys, this is actually the same as if you were to write it as n and then the whole bracket over 2. That would mean the same thing because this is all one term. All right, the formula is given like this on the formula sheet. They will ask you to prove it like this. So you can't leave it like this, unfortunately, as your final answer. This is equivalent to this, all right, where you are just taking this whole side dividing by 2, but you can just take the 2 and just write it under the n because it's still the whole thing multiplied together. It's still one term. Okay, and that is the proof for this arithmetic series sum formula.